are there any specific issues that you have that you want me to address? I'm gonna, you can tell me in general, and as we go on, I'll do that. But I want to start out if you have a specific problem. If there's a question on a quiz, if there's some material that was in the PowerPoints that you don't understand, a particular slide or something like that. Let's start with the specifics, and then we'll move on to the more general stuff. So, Jamar, Samantha, is there anything that fits the bill there?
For me, it was more specifically with R.
Okay, good. Right, working in R. How about you, Samantha?
Yeah, so I had a specific issue with R this week. It just one of the functions was not working. And
Did you email me about that? Were we getting a different answer on chat?
no, this just actually happened today.
Ah,
And so I knew this meeting was coming, so I just came here. And then I also had a question from uh last week's quiz, but I also can't remember what the question actually was.
you remember what the nature of the question was?
Honestly, no. I'm gonna try to remember though.
Okay. All right.
But yeah, my
So,
biggest issue is are not working.
so what was the command that you had an issue with? Was it glamps? Was it tidy? Was it?
It
Is it
was actually a few of them. So glams didn't work, tidy didn't work. Let me actually go back into it. And then I also couldn't
I can almost
load.
guarantee. I can almost guarantee that's a problem with either the package didn't install properly or it didn't read in the library correctly.
Yeah, one of the packages won't load. The stats R won't load.
Yeah.
Like it
Is
won't
it
install.
is the stats are is the name in quotation marks in addition to being in parentheses? I've noticed that
Yeah.
a lot of these exercises, they have left out the quotation marks. They left in parentheses,
Oh,
but
okay.
they tend to work sometimes anyway because before you got to that exercise, you did something on the same night that loaded the package that you needed, so you didn't really need to reload it, and it works, but you don't realize that there's an error there sometimes.
Let me see now.
Yeah, I had an
Um,
issue with the same thing. The dev dev tools
Uh-huh.
wouldn't work.
Okie doke. Okay, we're gonna actually give that a try. So I'm gonna start out with a blank sheet, a fresh new version of an R console, and I'm going to paste in a bunch of instructions, including the package installations in the library, and then a number of the different operations that we want to do for this particular week. So I'm going to give that a try, and we're going to run through it, and I'm purposely going to sabotage it to show you what happens when a particular package doesn't load. Okay, so for starters, though, I want to you mentioned quiz two. Let me just open this. Let me get this out of the way again now. And let's make sure we get that resolved. So one of you is in, I think, my in-person class, and the other is in the asynchronous class. Okay, go to quizzes through here. And I'm going to go to quiz two. Okay, so let's take a quick look at this. You think it was one of the first couple, or the last three are something you need R for? So, what you think it was one of those, or you think it was one of
no,
the?
I think it was not the one that had R.
Yeah, okay. Okay. Now this one, there was an issue. What was the issue here? Oh, the issue was,
Oh, yeah, this one made sense to me. I think
yeah,
now that I've got it, I think there was the graph.
yeah. In fact, I'm going to give everybody, I haven't done it yet, but I'm going to go back and give everybody points for this one because it's very easy to misinterpret this first part about, they're talking about 41% of all the participants identified as conservatives, but then it says 31% were in favor of citizenship. It doesn't say whether they're talking about conservatives or everybody. So, I mean, it was easy to misinterpret, and you only had two attempts on this. So a lot of students missed that because they did that whatever the answer was supposed to be, which is this one, they interpreted a different way, and which is makes sense. But anyway, let me get to the next question. This one is the box plot, and
Yeah, I think this is the one I had issues with.
okay, all right. So one of the first things you can do with this is you can drag out the image. And I think I even posted it at some place in the exercises. You can drag out the image so you can look at it separately. All right. So if I look at this, one of the principal things that I see is that the median, this really dark line is the median. The median looks like it's somewhere around 60. The interquartile range is a little bit lower than that, maybe 50 and to 70. So the interquartile range is about 20. And there are three significant outliers. One of them all the way up here at 550, almost 600 really, almost at 600. So those like kind of like tip-offs. So let's go back to the choices. So the choices here are, want to calculate which statement is correct about this box plot. You could use code. They give you an example of code that you can use to actually calculate the interquartile range and the mean and the median. So you could open this data or you could just take this and paste it into R, and it will give you the interquartile range and the mean and the median. Okay, so the median looks like it's about 70 in all of these. The mean looks like it's about 70. Actually, maybe I should actually calculate it so we know what it is. Yeah, why not? Okay, let's open R. See, I am doing the right one. This is the one that was an issue, right?
Yeah.
Okay, I'm gonna make a new project. Save that. Doesn't really matter. Yeah, say new project. I'm going to call it test today. And I'm going to say create the project. And we're starting with new. Remind me later. And first thing I'm going to do is, I'm hoping I don't need anything special to do this. So I'm going to copy this. And I'm going to see if I can get away with just pasting it in here. And I'm going to hit run. Oh, I'm going to hit enter. Okay, the interquartile range is 15. So that's probably something like 45 to 70, whatever it happens to be, is the middle 25, maybe 65 to 70 or something like that. Notice whatever is in the base R, I didn't need to do anything else, right? It was built into R. I didn't need to load any packages at all. So that happens to be present in whatever I had previously loaded, or whatever is what's included in the base R thing. Now, notice I didn't bother to drop this window. I'm typing into the console. I'm not typing into the programming window. The reason why I'm doing that is because it's just a simple command that I'm trying to execute. I don't need to, save this as a program. So I'm going to take the mean. We'll figure out the mean now. Enter. And the mean is 107. And the median, okay. And the median is this one over here. And I'm going to hit enter. I don't have to run. I just hit enter. And the median is 70. Okay, so now let's take a look at that box plot and see if that actually helps us. All of them have these two extremes here, 150, three extremes, 150, 280, 560. So they all seem to have the same outliers on the high end. So that's not going to help us much. So let's go to the picture. Where's the picture? There's the picture. And the mean, where was I here? So the median is, shoot, I kind of lost it here. If you want to calculate what is the current, what statement is current about this box plot? Let me see what the choices are. The median is 70, the mean income is 107, and the interquartile range is 15. So 15 and 70, that fits. What did it say? What did I say the mean was?
70, I think.
70, 70. So the median is 70.
Sorry.
The mean is going to be larger than that because we see that it's skewed to the left, right? And that was 100 and what was that?
107 maybe?
Yeah, I lost it here. There it is over here, was 107. So this one, 70, mean is 170, interquartile range is 50. That seems to fit in the 2 points beyond the whisker of 150, 280, and 560. So that seems right? So the mean to give the best indication of the typical income of in New York. That makes sense because you don't want to include that guy that's making $600,000 in the average, in your typical average income. The median is probably a better measure of what the middle income is than the mean is because of that excursion. So this one, median is the mean income is 70 and the median is 107. That's wrong. They're reversed, right? The mean is bigger than the median is because it's pulled out by that outlier. The median is resistant to outliers, right? So that one's wrong. The median income is 70, good. The mode income is 107. That's true. The interquartile range is 15. No, the median is not 107. The median, oops, I'm sorry. I should be looking at this one. The median is 70. That's good. The mode is 107. Actually, the mean is 107. The mode is 70, the one that turns up the most frequently. So that one's wrong. The median income is 70. Good. The mean income is 107. That's good. The interquartile range is 15. The 3 points beyond the whiskers are 45. We know that's wrong. 40, 45, 50. They're much larger than that, those outliers. The median income is 70. The mean income is 107. The interquartile range is 15. And the 3 points beyond are 150, 280, and 560. So the median might give the best indication. What was number one? Why was number one wrong? The mean income is 107. No, the mean income is, the median is mean. The interquartile range is the 2 points beyond the whiskers. 2 points beyond the whiskers then they name 3 points. They must mean 3 points. Could that be what is that like a trick?
I think the difference
that sounds like a trick question, right?
Yeah, and the first one says the mean might give the best indication. The other one says the median might give the best indication.
Oh, this one says so the mean. Oh, you're right. That's the reason why that one's wrong. This must be just a typo, right? That 2. That's really 3. So yeah, the only one that really works is the last one there. So does that make sense?
It does. Thank you. I appreciate it.
But isn't it cool that like when we're working with R, we don't have to. I can just type. But this is the kind of window you would have if you just ran R without having RStudio running, right? You just have a single window, and you would type in whatever instructions are and hit enter, and it would execute those the instructions that you gave it. That kind of programming language is called an interpreter. You give it instructions, it interprets it, and they take action. That's the nature of R. Many other languages like C and C++, Objective-C, all these other languages you hear about, they can be used as interpreters, but their main function is being used as something called compilers. For instance, when you download an app from the Apple Store or from the Android store, that app is a program altogether by itself that just runs. You don't have to do anything to it. You just install it and click on it, and it just runs. A programmer has developed that app, typing into a window as we're doing with R, but instead of individually executing the commands, he can then send it to a compiler, which takes all of the instructions he's outlined and turn it into a packaged program. So he can then sell it to you, and you don't need C++ or Objective-C or anything else to run it. You just need an iPhone or an Android phone or something like that and be able to download it and run it. That's called a compiler. What we're doing is we're working with an interpreter instead. So I could have done it this way, or I could have actually, typed all these instructions into this window up here, and the output would have appeared down here. I just decided, well, why do I need to do that? They're just individual commands anyway, and it gives me the same answers. Right. So we were able to do that. Okay. So now, what was I going to do next? Was there something else that we were talking about? Was it just the R stuff, or was there something else that came up?
Can you just check the ends? Like, I was a little confused, and I don't know why. Maybe I was just reading it wrong. The one about the flights
You
and
mean
distance
R, or is there
on the
another one
quiz.
here? Is that quiz 3? Quiz 2?
Quiz 2.
Let's see which one that's going to be.
It's quiz 2. It was like the flight time with distance.
In lab 2, what did you find to be the average miles per hour? It's not that one, right?
No, not that one, the other one.
Okay, there's 2 more, I think, that do this. How would you describe the relationship between distance and the average speed that you found? That one, or keep going?
Yeah, that one.
Oh, the speed had a curvilinear relation such that a positive relationship between distance and speed was less evident at long distances. In order to interpret that, you have to create a graph. So
Right.
you have to graph delay, the speed versus distance to
Yes.
see what the shape of that was. So you're going to be at a little bit of a disadvantage there because you have to interpret the graph. And what you should see there is you should see that it's not a straight line. So, like in other words, if you're going a long distance, your average speed in an airplane is going to be much higher than if you're going to a short distance. For instance,
Yes.
if you were going to fly from New York to Philadelphia, right? By the time you get to cruising altitude, you're coming back down again. So you're never
Right.
really reaching maximum speed. Shorter
Right.
distance, the lower the speed. Now the question is that a linear relationship? And to do what you need to do there is you have to plot the graph and then interpret the graph. Does it look like that? Does it look like it's really a straight line, or does it look like it kind of hooks a bit and then changes to a straight line? For instance, so curvilinear means that it's curved.
Right.
It's not linear. I'll tell you what. When we get into working with R, I'll see if we can't. I'll come back. We'll work on quiz 3 or the stuff for this week, and then I'll come back to that one, and we'll
Okay.
actually graph that as well. Okay, I got a couple more people just tuned in. Evelyn, do you have any questions before I get started on? We were talking about going over some of the R exercise.
I mainly have questions about quiz 3, the R related stuff.
Okay, now let's actually go dive into that right now, since that seems to be the big issue, right?
Thank you.
Okay, so let's go back here, and I'll get into quiz 3. Okay, and I am going to preview quiz 3 so I don't have to give up the answers. Okay, so I'll start. And okay. So not that I feel bad about giving up the answers, but maybe not, maybe eventually, but not right off the bat. Okay, the data set H5, okay, we used in this week's lab has information from each year from 2008 to 2016. By the way, if you try and use ChatGPT for help on here, one of the issues with ChatGPT is it's using a later version of HFI. It's using data from 2008 up to 2022. So it's not really exactly the same file. In fact, theirs may be called HFI underscore 2024 or something like that, or 2022. It may be, or it may just have the same name, and then like in the notes, it gives you like the version. Okay, so in this lab, we predicted personal freedom score, PF underscore score. Now, again, just to talk about the data set, what is this data set all about? It examines all the UN countries, 168 countries or something like that, I'm estimating, right? It examines each one of them, and they get a score for a number of different categories of types of freedom that they're allowed in those countries. It could be freedom of press, freedom of religion, could be freedom of association, it could be freedom to travel, and so on and so forth. And then it has one particular score, which is a composite of all of them called personal freedom underscore score. So this is kind of a composite of all the others. So the question that we're running into here, this is the nature of the relationships that we're looking at, is how do all these other variables stack up in terms of their influence on the overall personal freedom score? Do they have a big impact or they have a small impact? So what statistic do we use to measure that impact? Well, what we do is we say to ourselves, let's set up a linear model. Let's assume that the relationship between personal freedom score and these other variables is a linear relationship. And so if it's a low score, the personal freedom score is low. If it's high score, personal freedom score is high. And it's going to be a dot. Your scatter dot is going to be 168 dots or whatever number it is. Each one is going to be for a different country. And the x-axis is going to be the predictor, which is going to be whatever it happens to be, personal freedom, religion, or something like that. And the y-axis is going to be the score you're predicting, your outcome, right? And that's going to be PF underscore score, right? The personal freedom score. So each one of those dots is going to be the x-axis, the x value representing the predictor variable score, and the y-axis representing, for that same country, the personal freedom score. So if we really want to check to see if it's a linear relationship, we would create a scatter plot for every one of those relationships. We'd create a scatter plot for personal freedom score versus personal freedom of expression, personal freedom versus personal freedom of travel, and so on. So we create a scatter plot for every one of them and look to see if that was a linear relationship. We didn't bother with that here. We just assumed that they were all linear relationships so that we could continue with what we wanted to do here, right? So in this case, what they're asking us now is to, for each year from 2008 to 2016, we want to predict the personal freedom score, right, based on the personal freedom of expression control. So in other words, if we know what this is, what would that suggest that this is? Please conduct an analysis predicting personal freedom score, personal freedom control for each year available, and then select the correct statement there. So how do we measure the strength of this association? The amount of influence, in this case, we're looking at personal freedom of expression control. How do we quantify how much of an influence that has on the overall personal freedom score? Well, we use R and R squared. R is a measure of how good the associations, how good the correlation between these two scores is. And R squared actually quantifies what percentage of the personal freedom score is determined or predicted by the predictor variable, in this case, personal freedom of expression control. So if R is 0.7, okay, R squared would be 0.49, or about 50%. That would be saying that 50% of the variability in the personal freedom score can be attributed to what the personal freedom of expression control value is. If R was equal to 0.5, R squared would be equal to 0.25. So 0.25 says, that tells us that only 25% of the variability in the personal freedom score can be attributed to personal freedom of expression control. Much less valuable predictor of what the personal freedom score is going to be for any individual country. Notice how big an impact that has when you square it. 0.7 versus 0.5 is a difference between 50% and 25%. It blows up, right? The big difference in that. Now, it's entirely possible that you would get a situation where it's a perfect predictor. In that case, the R would be 1 and the R squared would be 1. So 100% of the variability in personal freedom score is predicted by that other variable, personal freedom of expression control. So now what we have to do is we have to calculate the R square value for every year from 2008 to 2016 for personal freedom score versus the predictive variable personal freedom score underscore control versus the output variable personal freedom underscore score. So I'm gonna open up R. Okay, R Studio. I'm gonna open up R Studio. Remind me later. I'm gonna separate these two. Okay, so now I want to get started with typing in these instructions. Now I could start typing and just like type in everything I need, the packages I need, the libraries I need to open, and I could start sorting, filtering the year, so I get the whole HFI, and I sorted into the 2008, sorted into 2009, and then run all of the commands and so on and so forth. I could start doing that from scratch, but that's kind of an onerous task. So we're going to take advantage of the fact that this stuff is all just text. It's just like you could save these as a Word text document or a text editor document. So I'm gonna go to my little folder here. I uploaded this into the announcements for Blackboard. And let's see, review session. Should be a folder because, yeah, we go, review session. So I'm going to open this up and let's see. Which one did I do here? More practice. Review session. Okay, I'm going to open this. Why did I do 101A? I don't remember. One's a Word document, one's a Word text document. The other one's just a plain text. Doesn't matter which one. So this is a text edit on the Macintosh. It's just like a text editor. I forget what it's called on Windows. It's like Notepad or something like that on Windows. So anyway, here is something I put together for myself to make it easy for me to do these various exercises. So I'm just gonna copy all this text, just as if I had typed it in from scratch. I'm gonna say copy. I'm gonna go into the editor window and I'm gonna say paste. Okay, paste, and bingo, there it is, all there. And now I'm going to go through the steps that I would do to execute this code and actually get the R-square values for the 5 years that they were talking about. Okay, so the first thing I'm going to do is I already played around with some stuff here before. So I'm going to just tell it to kind of reset things, clear out any variables I use or anything like that. So I'm always going to start with this remove list equals ls. Ls stands for list catalog listing, whatever's in the folder. I'm going to say run. Good, it does that. Look down here, I didn't get any errors or anything like that. And now I'm going to go ahead and install this. So now let me see what happens if I just click in there and hit click run. Okay, so it goes through all this. I get a lot of red tape and stuff like that, but it doesn't say anything about an error, right? Well, hang on a second. Let me do something else. Let me take away these. And I'm going to say run again. Oh, bingo. Error in install packages. DevTools not found. There's a good shot that if you're not finding it, it's probably because of that. Okay. And I noticed that on I didn't create, the stuff that's on the course site are not packages that are not scripts that I created. But I noticed that a lot of times that they will omit that and it'll run anyway. And you might get that error, but you'll still be able to work anyway because it's been loaded previously. Like right now, I don't even have to hit run again because I've already loaded it. Once it's loaded into R, you could start a new project next week and it's already in your R. All you have to do is use the library command to activate it. This one might be a little bit different because it includes a special set of developmental tools. Now, it's kind of surprising that this would give you a problem in actually executing the code here, because most of the stuff that's in here is stuff that programmers use to help them create new packages. So that's the core reason for dev tools. That's why it's called development tools, right? So I'm kind of surprised that it would get in the way. So you may get an error, but there's a good shot things will work anyway. If not, just fix this. It should work after that. I'm just going to click run again, and it's going to do it again. And then I'm going to install Tidyverse. And yeah, fine. Now install Open Intro. Now install packages. It's advancing to the next line. I don't know if it may not be that easy for you to see. I could click in here, make it a little more obvious, and run Broom. And again, I don't know why it insists on throwing up all this red text, because none of that is an error. Okay, so now I have to make these available. Let me go over here to click on packages. And you notice that base, the R base package is checked off. These are all libraries. These are all packages that have been preloaded or that I've added over the time that I've worked with R since I installed it. They stay there until you take R off your computer and reinstall it. Then you start from scratch, if you ever want to start from scratch, right? So right now, the base functions for R, which includes some statistical functions, those base functions are already loaded and they're already available, I guess by default, because I didn't open them in the library, so they must be open by default. But let's see Open Intro. Open Intro methods. Here's Open Intro. Open Intro it's been loaded, because I hit install packages, open intro, right? So it's been loaded already, right? But it's not available. It's not checked off. It's not available for me to use the material, the files and the commands that are part of the textbook material. Part of the stuff. This package was created by the Open Intro group who created our textbook. Okay, so Open Intro is not working. But if I go over here to the library, click in there and say run, bingo, check. Now it's checked. So I could go through here and check these to open them, or I can continue to run the various library commands. So I'm gonna now open library stats R. Okay, and it worked. A lot of red type, but it no errors. Broom, and the broom seems to have worked. And tidyverse. Okay, tidyverse, that has a lot of functions that I actually, this is wrong. I need to edit that. Tidyverse has a lot of functions that help you format your output data into things that are much more readable. So for instance, glance or tidy, they're probably part of that. They probably won't work if you don't load tidyverse and open the library for tidyverse. Okay, so now I'm gonna take a quick look at HFI. One of the easiest way for me to do that is use the glimpse command. The glimpse command shows all the columns and data types and gives you a sample of them, gives you like, the first few values, for you to look at for each one of the variables. So glimpse, parentheses, HFI, I'm going to hit run, no quotation marks. I'm going to hit run, and it shows me all of the variables and some of the data, the beginning of the data for each one of the variables that are here. Personal freedom expression newspaper, personal freedom expression jail, personal freedom expressions, et cetera, et cetera. If I go all the way back up to the top, it shows me there's 1,458 rows of data and 123 columns. There's 123 variables, but there's 1,458 rows of information here. Well, I mentioned there's only like 160 countries in this survey. Why is there so many? Because each country is here for something like 8 years, right? 2008 to 2016, or 10 years. 8 years. That's why there's so many rows. Okay, and in fact, you can see that the countries, Albania, Algeria, and so on and so forth, those are the under countries. Those are the first set of data in that values in that particular variable. Okay, so now we know what we're kind of dealing with. So our question is, what was our question again? Hang on a second, let me go back and find our question. Okay, I closed it up, I guess. Maybe not. Maybe it'll pop up again when I do this. Yeah, here you go. Okay, so we want to know whether it's we want to predict personal freedom of expression control versus personal freedom score. Conduct an analysis for each one of these years and figure out where was the slope the steepest. Okay, and the R square the greatest. Slope. So we got to calculate the slope and the R square. So we need two commands to do that. The first thing we got to do is we have to segregate this into just the values for that year. 2009, this is miserable. They really could just make it consecutive, right? 2009, 2012, 2013, 2014, 2015. Somebody keep track of that for me because I'm never going to remember. I'm going to start with 2009, 2012. Okay, so now, first thing I need to do is I need to just look at what we have for 2009. So I'm going to change this to 2009, and I'm going to change this to 2009. So what does this command do for us? If you read the comments, it'll explain it to you. But I can tell you right now that it takes the file HFI, that's the total file with all the years, 1,428 lines. It runs it through a process. The process in this particular case is called filter. And what we're doing is we're going to filter that file on the value. We're going to take the variable year in that file, and we're going to say we're only interested in 2009. Only copy over the information to this new file, HFI 2009, only copy it over if the year is equal to 2009. So I'm going to click in here and I'm going to click run. So now I didn't get any errors, so presumably it did that, but all it does is it shows the command executed down there. It doesn't tell you what it was. So now I can just, if I want, you don't have to, but it doesn't seem like there was an error. I'm going to say, let me take a look at it now to make sure it works. So I'm going to glimpse HFI underscore 2009. Got to change that too. Okay, I'm going to have to change each time we do this, we're going to have to change it. I'm going to click run. And now if I go down here and I scroll back up, let's see how many rows of data we have now. Well, now we have 123 columns of variables. That hasn't changed, but we only have 162 rows of data. That means 100, each country has a line. So there's 162 countries that are represented here. So it worked. All of the data in here is for the year 2009. That has worked for us. So now that I've done that, now I want to see what is the relationship between, for the data file 2009. Again, I got to change this. I got to identify what data file I'm working with. I have to tell it that I want to create a linear model, right? LM is for linear model, in other words, a regression. Okay. And that linear model is going to be comparing the predictor variable, PF expression. What was expression control? Is that what it was for this? PF expression underscore control. Command Z. Okay, PF expression. I got to click away from that. Underscore control. That's my predictive variable, and my outcome variable is PF score. Okay, we can also call this our independent variable and our dependent variable. So the second one is our independent or predictive variable. The first one is our outcome variable. So now what's going to happen, it's going to create a linear model, and it's going to store the information on that linear model, the results for 2009. It's going to store it into this file called M23, into this variable called M23. There's a better name for that. It doesn't come to me at the moment. So now we want to take a look at what's in M23. So I'm going to use glance, and I'm going to click on parentheses M23 to give me what is that's in there now? So I'll click run, and what's in there now, I think, did it give me an error there? Oops, glance, M23, linear model. Did I run that? I don't even know if I ran that. Okay, let me try. Let me run that first. Okay, so tidy gives me the slope. Remember now the estimate represents the slope and the y-intercept. Okay, this is your slope and this is your y-intercept. Okay, so this gives us the information we need to write a formula, a straight line formula, in order to express the relationship between personal freedom expression control and personal freedom score. So that worked there. Let me go back up to glance. Well, I think it's glimpse. Did I mistype that? No, there it is. It worked this time. I don't know why it didn't work that. Maybe I didn't run it correctly before that. Okay, so glance tells us the R-square value. Now, you'll notice that there's an R-square value and there's an adjusted R-square value. They're almost exactly the same thing. And in fact, the reason for the adjusted R-square value is because in the next week or two, we're going to start talking about multiple regression. And in that case, what we're doing is we're creating a regression where we're not just using one variable, one predictor variable, we're using multiple predictor variables. So we might use personal freedom as press, personal freedom of mobility, personal freedom, and so on and so forth. You might use several of them to get a better prediction of personal freedom score. That's great because there's a good chance that may improve your ability to predict what your dependent variable is, the value of dependent variable, or your outcome is. It might help you out. But problem is that it's very easy to include variables that really don't help. And R-squared is an adjustment for the number of extra variables that you have to use to get a prediction. So it's a little bit of a slap on the wrist for using too many variables in your prediction. So basically, if you use just one variable, R squared and adjusted R squared should be exactly the same thing. It's not exactly the same thing. If we have time today, I'll explain why it's not exactly the same thing. But this is just a remnant of the way that the calculation is done. In fact, if you can see that it's almost the same anyway, but if the sample size is very small, the difference between R squared and adjusted R squared is going to be bigger, even though there's only one variable. If the sample size is larger, is very large, there'll be almost virtually no difference between these two. So they'll get closer and closer together based on the sample size. But that, again, this is just a remnant of how R squared is calculated. It really doesn't mean it. So if you're reporting something, if you're doing study and you're only doing a simple linear regression, just one variable, you should report R squared. If you're doing a multiple regression where you're reporting three different variables as part of a multiple regression, you should use the adjusted R squared to get the proper value for a regression that has all these extra variables, whatever number of extra variables you have. Okay, so I hope that makes sense. But for the time being, if we get to it, maybe not now, maybe at some point in the future, I'll show you the formulas, and you'll see why that happens, even when we have one variable, and it really shouldn't be different. Okay, so anyway, so now we have two values that we need. We have the value, we have the slope, which was 0.339, and now we have the R square value, which is 0.376. So if I go back to the question said the slope was steepest in which of these years, and the R square was greatest in. So you got to figure out whether it's that you have to do almost every year here, right? You have to do 2008, 2009, 2010, 2000. You can skip 2011. How about 12? 12, because you need to get R. It's not all. Some of them they want R square, some of them they want slope. So you basically have to do almost every year. You can get away with 2013, 12, 8. They got 9. I don't. Yeah, 9's here. 14, 13, 14. You have to do every year. You have to do every year from 2008 to 2009, and then accumulate all of the R squares and all of the slopes for each one of those years, and then look at the question and compare them and see what the answer is. Okay, so I'm going to stop for a moment, and I'm going to ask you guys, is that okay? You guys, does that make sense to you guys? Was what I've done here make sense to you?
Some of it makes sense, but could could you explain why you put M23? Like, why did you choose the number 23?
Because they happen to use M21, M22, M23 as holders for the results of linear regression in a lot of these exercises. So I just did it out of habit. Could have been M1, could have been M14.
Okay. Because it said M1. I changed it because you did 23, but so it could have been really any M.
Yeah, let's give it a try. Why not?
Okay.
Let's try it. Here, let's try this.
Thank
M1.
you.
Okay, I'm gonna click run. Then I'm gonna go over here to glance, click M1, and click run. Okay, and I think it did it. Yeah, it did it. And then I'm gonna tidy M1 and click run, and it did it for that also. Yeah, that's
Okay, perfect.
Yeah.
Thank
So like I
you.
said, in my case, it just happened to be habit.
Got
Anybody
it.
else? Jamar, how are you doing there?
I'm a little lost, but I'm trying to follow along, and
Okay.
then I'll rewatch the video
Okay, I'll make sure.
because it's like hard for me to see it, but
Okay.
so I'll rewatch the video again.
Now, we have a choice. We can sit here with me doing this until midnight, or we can go on to the next problem. I suggest we go on to the so
No, yeah, for sure.
Yeah, you know what you guys got to do now, right? You have to, next one's going to be 2010 and so on and so forth. But you got to change it in each spot, and you're also then, and it's always, that one always uses personal freedom expression control. So you don't have to change the variables. You just have to change the year in each case. And then you got to keep track of the answers for each year. So then you can go back to the question with the 10 slope. I think it's like with 8 slopes and 8 R squares. And then you can answer the various questions that they have there and interpret properly. Okay, let's go on to the next question. Okay, which of these variables in the HFI data set best predicts EF underscore? Okay, so which of them best predicts this value EF underscore score? Okay, so EF underscore legal, EF underscore money, EF underscore trade, EF underscore. So what best predicts? What was this one before? This one was 5 levels. This one was personal freedom. So what does EF stand for? EF legal. You know, one of the things you can do here, which is cool, is I can go over here to files, or I can actually go here. I'm going to stick in something here. I'm going to go up here, and before even all of this stuff, I am going to, up here by glimpse and so on, I'm going to put in question mark HFI, enter, and I'm going to click run. And what that does is it pulls up the code book over here for human freedom. There's the code book. So now I can search in the code book for EF underscore score. And that is the economic freedom score. That's what EF score stands for. And then you could actually do that for EF money. So we can interpret now. We don't have to read every one of them. Now that I know what EF stands for, economic freedom legal, economic freedom money, economic free trade. So we're going to compare each one of those predictive variables to EF score to see which one of them best predicts it. What statistic should we use to take one predictive variable and decide how good it predicts this outcome variable? What did we just use? We just used R squared. And we're going to use plain R squared, not adjusted R squared, because only a single variable. We're going to try this one first, next one first, next one, and so on and so forth. So in some sense, this is a little bit simpler than what we were doing before. So I am going to start with EF legal. And we're going to compare it to EF score. So now what do I have to do now? For first, what I have to do is, first of all, it doesn't say any particular year. It's talking about the entire data set, right? So first thing I'm going to do is I'm going to say, we don't have to filter it. We can just use HF, right? So now I am going to go here to create my linear model. Okay, and I'm gonna copy this and I'm going to paste it down here. Whoops. Paste it here. Okay, so my linear model is going to just be the data set HFI, right? The entire data set. And my outcome is going to be EF score, right? And my independent variable in the first case is going to be legal, EF legal. EF underscore legal. Okay, so now what am I going to do here? So I'm going to do a linear model for for EF legal predicting EF score. And I'm using the entire data set for HFI, not any particular year. It's going to click run. Okay, and then I'm going to say, okay, I put it into M1, so it erased what we had before. Okay, and I'm going to glance at that. And now there is my R squared. My R squared for EF legal versus EF score, what percentage of that score is predicted by EF legal? It's 61% is predicted by EF legal. So now I'm going to do it again, except I'm going to do it for money. Whoops. EF money, going to run it again, and I'm going to do glance again. Remember, I don't need tidy because it didn't ask for your slope. Run. Okay, and it's equal to 66%. So I got 61%, 66%. So far, money is in the lead. Okay, and how about trade? Okay, let's say trade. I'm sorry that other question is torturous. It's gonna make you do it so many times, but I guess each time you do it, you kind of get a little bit of muscle memory in there, right? So you have trade. I'm going to click run. and I'm going to use glance to tell me the R squared, and it's 0.78. Oh, wow. 77, almost 77% of the variability in economic freedom score is predicted by the economic freedom for trade. Okay, and then finally, we have to the last one, regulation. Economic freedom regulation. I'm going to click run, and then I'm going to glance one M1, and that one's 63%. So the big winner here was economic freedom. I think trade was trade, right? Is that what I did? Yeah, it was trade. So the one that best predicts economic freedom score is the value for economic freedom of trade, right? So that's pretty straightforward. That one's easy, right? Okay, we didn't have to go through so many permutations. So let's take a look at number 7. In the data set HFI, the personal freedom score is made up of personal freedom of whatever the hell that is, ROL, personal freedom of SS, personal freedom of movement, personal freedom of religion, expression, and identity. So we got 1, 2, 3, 4, 5, 6. Okay, now, when I first looked at this, I kind of, a chill went up my spine because I said to myself, are they asking about multiple linear regression? Do they want you to do this like adding one variable in at a time and then taking it out, so on and so forth, and all 6 variables at the same time? And then I said to myself, well, they can't do that in this quiz because it's only quiz number 3, right? I mean, it's only quiz number 3, session 3. We haven't covered multiple regression yet. So it's got to be that they want to know a PF score, which of these factors contributes the least to the total score. They're interested in what is the lowest adjusted R square. Now, again, I don't know why they're saying R square here, because R square should be the same if it's the way that I think they want you to do this. So what I'm going to do is I'm going to suggest to you that all you're doing again is calculating R squared. It really doesn't matter for our purposes. It could be either adjusted or non-adjusted, right? Because they're almost exactly the same thing. And then you're going to do that for each one of these different variables, and then determine which of the one has the lowest R squared, which means it contributes the least to the value of the variability of personal freedom score, right? So basically, you would personal freedom ROL, and this is, again, it's just the entire data set, right? So you would go back here, and I wonder what ROL is. Let's go back and find out what ROL stands for. I'm kind of curious. Run. Okay, and ROL, search for ROL. Okay, is it ROL score or is it just ROL? I think it was just ROL. Personal freedom is procedural justice. Okay, whatever. Okay, so less exciting than I thought it might have been. Okay, so now we're not going to bother to filter it into different years. We're just going to use HFI. So we're going to predict the value of R square for personal freedom score using PF underscore ROL. Personal freedom score, PF underscore ROL. Oops. PF underscore ROL. And the data files HFI. We're not going to pull out different years. Personal freedom score ROL, EF score, and is not EF score. We want personal freedom score. What was it again? Personal freedom score, PF. It was PF score, PF underscore score, PF underscore score. So we're going to use the data set HFI, and we're going to do a linear model where we're using PF underscore ROL. Has something to do with something to do with justice, and we're going to use that to predict the overall score for personal freedom for that country. And so this is our predictive variable. This is our outcome. Another way of expressing it: independent variable and dependent variable. And we're going to take the results of that linear model, and we're going to put it into M1. I'm going to click that and click run, and then I'm going to use glance to give me the R square value. Run, and down here in this window, it gives me R square value. So R square is equal to 0.60. R square, adjusted R square is 0.599. Notice how much closer R squared is to R squared is to R, adjusted R squared this time than when we did it for 1 year. Anybody think they know why it's so much closer than it was before? What did I tell you about the relationship between R squared and adjusted R squared when you only have one variable? They're really the same thing, but the way it's calculated means that they're going to be off by a little bit. But what's going to impact how much they're off is the sample size. Before, the sample size, when any individual year, sample size was 160 or 162. Now, since we're using all of HFI, the sample size is 1,428. So that's why the sample size is so much bigger. That's why R squared and adjusted R squared are virtually the same number, down to the third decimal point. Okay, so we did that. I did that for the first variable. You'll do that for the second variable, the third variable, the fourth variable, and the fifth variable, and you'll be able to then, compare them and decide how to answer that. This time you're going to be looking for. It told you to look for the adjusted R squared. I doubt it's going to be different than the R squared, but then this time you're going to be looking for the one that least impact on personal freedom score. So you're going to be looking for the lowest R square value, not the highest R square value in this case, and that should be the answer to that particular question. So again, you see me taking the same code that I've been using before and just repurposing it rather than typing from scratch and so on and so forth. But the key here is that usually if something doesn't work, it's because your syntax is wrong. In other words, and again, if you look back over some of the exercises, I do know for sure that sometimes when we had the initial exercise, and then we went into the more examples, right, or the instructor exercises, right? We usually were using the same window, but when we opened up the new window, we had already installed the packages that we needed. So when it was missing the quotation marks, we didn't notice it because we already had them successfully installed and opened already. If you even remember from the library command, most likely, if all I did was open a new file, right, the package is already there. So if I created a new project, then I would have to go through all the installs in the libraries. But if I just added commands to this, I wouldn't have to redo this, right? So that's where we're at. So the other thing I wanted to cover is just so that we understand, why are we doing this? What is this all about? Why are we doing all this? And for that, I want to go to OneNote. Okay, so I put this together here just so you can see what's going on here. What we're trying to do is we are taking, let me squeeze this together a little bit for now. I can make it bigger. Okay, good. Okay, so so our scatter plot for the various values that we're interested in may look something like this. Right? There's going to be 160 for any particular year. Like this, I think was for 2016. Any particular year, there's going to be all kinds of dots here, X and Y values for different countries. This axis, the X-axis is the predictor variable. In this case, it's personal freedom of expression. And the Y-axis is going to be PF score, overall personal freedom score, right? So for each one of these dots, this would indicate that this is the X value for that country, and this is the Y value. The height is the Y value for that country. That's X and Y. So we want to draw a line that best fits this data that we're working with here. Okay, and that line, what we're trying to do when we fit that line, or the math that we use to fit that line, what we're going to do is we're going to draw this line, and the line that we want to draw is such that the differences between the value, for instance, this country here, we would have, the X value is here. We would have expected it to have a Y value on the line here, but instead the actual value is up here. So this is called our error, right? That's our error, also called residual. That's a residual as well. So we want to minimize all of these residuals. But problem is that, you know, as we've worked on in the past, if we just take all of these and all of these ones that are positive, the residuals, all these where the residuals negative, and you just add them together, they just cancel each other out. So it's not going to help us that much. So what we do instead is we just take all of the residuals, all of the differences, and we square them. So whatever this was, if this was 2, right now we have 4. If this one is 1 squared, it's equal to 1. If this one is 3, we square it, it's equal to 9. So what we want is we want the sum of all the squares, all of these, whether they're bigger or lower, because they're all going to be positive numbers. We want them all to be added together, and we want to get the sum of all the squares of the errors. We want the sum of the squares of the errors to be a minimum. We want it to be as small as possible. And the way we do that is by getting this line to be fitted so you don't have values that are very far from it. Like, in other words, if I drew a line here, I'll draw this down here. If I only had a couple of values like here, here, and here. If I drew this like this, if I drew it so that both of these were on the line, and this residual was, like, say, 10, right? Okay, then the sum of the squares, even though these two are right on the line, sum of squares is going to be equal to 100, right? 10 times 10 squared is 100. So now if I instead drew this so that the difference between each one of these two is 5, and the difference between the line and here is 5. In other words, it's in the middle here between them. Now, if I add up the squares, 5 times 5 is 25, 5 times 5 is 25, 5 times 5 is 25. It's actually only 75. So even though these were right on the line, the fact that this one was so far away is blown up by the fact we're squaring that number. So that's our objective in drawing this line. So now we don't draw that line because for us to do this for 162 numbers, for 162 values for 1 year is going to be impossible, basically. For us, we use a computer to do it. So the computer tells us 2 valuable things that we need to know about this line. It tells us the y-intercept, and it tells us, underestimate, it tells us the slope of the line. The slope, the amount that personal freedom score changes as the personal freedom of expression changes. So what is that formula for that line? That formula is y is equal to beta 0 plus beta 1 times x1. Well, what are these? Beta 0 is the y-intercept, and beta 1 is the slope, and x is the value for personal freedom of expression. And in this case, we could give it a specific number or whatever, but if we want to calculate it. But in general, we want to write a formula that works this way. So what in our case, what would that formula look like? That formula would look like this. Okay, so the formula would look, let me do it up here. That formula would be equal to y is equal to beta 0. What's beta 0? Beta 0 is 0.997 plus the slope. Beta 1 is the slope, which is 0.779 times the value of x. Right? Well, what's x? X is our predictive variable. That's personal freedom of expression. What is y? Y is our output variable. In other words, the predicted variable, the independent variable, the dependent variable. So if I go down here, now I have a formula where if I know what the personal freedom of expression, what the value for this for any particular country, I can use this equation to predict what the personal freedom score is. So that's really what this is all about, is to be able to make this prediction. This number, the y-intercept, it's nice. We need that to be able to draw the line and get some real numbers out of this. However, the real key here is the slope. What does the slope of 0.779 tell us? That tells us for every 1 that the personal freedom of expression score goes up, the personal freedom score goes up 0.779. That's the slope. Change in y, right? The change in y is, change in x is 1. The change in y is 0.779. In other words, change in Y over the change in X, right? So that's great. If the personal freedom of expression score goes up 10, then we're predicting that the personal freedom score goes up 7.79. If I want to actually calculate that if the personal freedom score is 10, what's the personal freedom? A personal freedom expression score is 10, then I would actually say personal freedom score is equal to 0.997 plus 0.779 times 10, and I would just simply solve what the personal freedom score is. So I could do that. Okay, so that's really what this game is all about. We want to know what that slope is because we want to know what kind of influence this variable, this predictive variable, has on our dependent variable, our output variable. And it's going to come up over and over as we go through this. This is going to become, you're going to get accustomed to this, and you develop a better feel for a better understanding of it. Okay, so that's really what we're doing here. Let me think if there's anything else that's really vital here that I think you need to consider. No, I think I left you with enough to do, right? I mean, just that one problem, you're going to have to, a number of permutations you're going to have to do to get your R square and so on and so forth to that one problem. It's going to keep you busy for a while, but then you'll get used to this idea of modifying the scripts, as you work. Any other questions? Are you all charged up? Do you think now, oh man, I can't wait to get to the computer and solve that problem number 6 or 7, whichever one it was?
Yeah, that was very helpful. Thank you so much.
I want to hear some enthusiasm now. Okay, we're all charged up, right? We're gonna go charge on to
So excited.
Maybe you'll catch a nap tonight. Maybe work on it in the morning. Okay, but I'll try and get this recording up tonight, so you have it in the morning if you need to go back to it. Are you okay on there, Jamar?
Yeah, yeah.
Okay,
I'm
good.
gonna attempt it again. I just know I had like issues in the very beginning
Yeah, I'll bet you.
R
Yeah, I'll bet you if
with
you go back.
when I was trying to do the packages,
Yeah,
it kept giving me error messages. It wouldn't
I'll
download the
bet you.
specifically dev tools.
Yeah, I'll bet
But
you.
now I know I could just go in and manually click all of them,
Yeah.
right?
Oh, as a matter of fact, if you go on to the announcements, this file is on there. You could just copy and paste this in
Paste it.
to the programming window, and it
Okay.
worked for me, right?
Yeah.
I had the hang on a second, library. Yeah, as long as those quotation marks are there. So you saw me go through it. It should work for you as well.
Yeah. Okay.
And
And
I
then
would suggest just for the hell of it, start with a new package. In other words, here, let me go back to R.
yeah, that's what I'm gonna do.
R Studio. Okay, and the way I would do that is go up here to File, say New Project.
Yep.
Okay, I don't care. I'm not gonna bother to save this. Okay, it opens up this window. I say let's create a new directory.
New directory.
Folder.
Yep.
Okay, that's a new folder basically, and we're going to create a new project. And the directory name, the folder name, is going to be whatever you want to give it. I tend to keep this stuff on my desktop, which turns my desktop into a mess, but it means I can find it, right?
Right.
So whatever whatever I want to call this, I'll call this Fred. The hell of it, right? And I can browse and put it somewhere else, that folder, if I want to, right? And I say
Okay.
create project, and I got a fresh project. And I could, if I want to, I normally ignore the updates until things don't work. And then if I want to make sure I got 2 windows, I just click on that. So that little double window up there, so that I got both my programming window and my output window, my console window. And in here, I can paste my.
Where are you clicking for that to get the 2 windows?
I'm going to click them away.
Oh, okay. I see it now.
Yeah.
I see what your thing is. Yep.
Here.
Okay.
Yeah, this is the way R Studio tends to open up. So
Yep.
all you have open right now is the console window, right?
Yep.
So if you click on that, it'll separate them, and you have the source window and you have the console window down here. So your instructions are up here, right? You can paste in that text file. You can paste it in up here, and then as you run through it, your output will come out down here. If you just got to do a quick command, you could just do it down here, right? Whatever, HFI.
Okay.
Yeah, right. You could do it. You could do it. I don't have anything installed. I started a new project. Nothing's installed, so nothing's going to work
Yeah.
right now. But you get the idea. You could work line by line down here in the console, but it's easier to have it have it all script in the program window. So then you can go and reuse that code.
Right.
You can modify it the way I did. I didn't do a lot of typing, right? Really, the only typing I did was to change the variable names or the file names for
Yep.
if I was filtering it.
Yep.
Okay, good.
Okay. So I'll
So
give it a try.
okay, for you guys in the live class, I'll see you guys on Thursday. And for you guys that are in the asynchronous class, use the discussions forum. I'm not a mind reader. You need to tell me if you're having problems or something like that, or something's not working, or there's a quiz problem that's unfair or something like that. So have a good night, guys.
I have one more question, if it's
Sure.
okay, about the quiz. It's actually the first one with the about like predictive and causal.
The first one on quiz 3.
Yeah.
Okay, let me get back to that.
Like I understand the concept. It's the actual
Yeah, let me take a
examples
look.
that I think are
Yeah, and let's see if question 1. Of the observed associations listed before, which are likely to be predictive and which are likely to be causal? So I think the key here is think about whether or not the one variable causes the other or just predicts it. So does
okay.
poor memory cause dementia?
No.
No, it's a predictor of dementia,
Right.
but right,
Okay.
so that one's predictive. Does weight loss cause cancer?
No.
No, bingo. So it's got to be predictive, right? It is predictive, right? Because you lose a lot of weight. That's one of the symptoms. Does high blood pressure cause heart disease?
Sometimes.
Yeah, it does. Sure. Never, not sometimes.
So it doesn't have to be like an always.
Yeah,
It's just like if it does.
Oh, no. I would say you don't have, no, in other words, you don't have to look, we're not, cutting corners here. We're not, parsing these like
Okay.
microscopically, but yeah, you have high blood pressure. There's a reason why they want to control your blood pressure because there's
Right.
you have all sorts of, coronary disease that's caused by high blood pressure.
Mhm.
Does vitamin D cause longer life? That's a good one. What do you think? Does
I think there's
vitamin D
studies that say yes, but I don't know if that's like
hang on a second. Let's take, okay, if it's vitamin D, does that cause longer life? Let me think about that for a second. Is it predictive of longer life? I would say it's predictive. I guess you could argue that like supplements with vitamin D probably contribute to better health, maybe longer life. But we're going to check I'm going to give you the answer, by the way. I'm going to actually look it up since I came across one that made me stumble. Does lack of vitamin C cause scurvy?
yes.
Absolutely, positively, right? Okay.
Mhm.
Yeah, we know that from from pirate, from pirate movies, right? So the only one we're wondering about is does vitamin D cause longer life? I know they make me take vitamin D because as you're older and you don't spend as much time in the sun, you really need a supplement, and it's important. It has something to do with cardiovascular disease.
Well,
Okay,
based on process of elimination, the answer is A, B, D.
what is it asking for? Which will likely be predictive. So predictive, we definitely A is predictive.
Mm-hmm.
B is predictive, and we think D
Has,
might be predictive.
yeah.
D, right?
Mhm.
Okay. Is there any other that? Yeah, if this wasn't predictive, right? If this wasn't, well, hang on a second. It's asking for which are likely to be predictive. So A is predictive. B is predictive for sure. So A and B. So the only A and B here is this one.
Mm-hmm.
So they're saying D is also predictive. It's not causative, it's predictive.
Yeah, just by process of
Yeah,
elimination.
that's that's I don't know about that, but I do know that A and B are predictive, not causative. Right?
Right.
Right. Since there's only one of them that has A and B in it, it's got to be this one. So they must think that D is also predictive, right? They have vitamin D. Maybe they're thinking vitamin D levels, natural vitamin D levels are predictive, right? Could be. Maybe they're looking at it that way. This is another one of these. I'm the messenger here. Don't blame me. That somebody else made this question up. But I agree. This one's a tough one. But fortunately, in this one's the only possible answer anyway, because we're sure about A and B. And let me see let's go back to the answers and I'll tell you if that's right. Hang on a second here. Come on. Let me see if I can go back. Yeah. Can I do this back? Can I go back that way? I'm on preview. I'm going to have to go back here. What number was that? That was number 1. Yeah, that's the right answer on that one. Yeah. So fortunately, all you need to know is A and B are predictive.
Mhm.
You don't want to answer that one. Okay, guys, have a good night.
Thank you very much.
Take care, guys. Bye.
Good night. Thank you.